So now we look at question 2. Using your graphs from question 1, it basically says plot out yet again a good look at 0 to 200. And it wants us to find the fraction of molecules that are in the speed range of 100 to 200. If you use a polynomial fit in Excel, find the order that best fits the graph. And you know, if I'm not mistaken, normally a quadratic or cubic, I wouldn't go higher than that, but either one is fine. You'll use it to integrate to find the area under it. So 4 decimal places, you simply integrate it with the limits of 0 to 200. So I'll show you a quick look at what one of these would do. If you had, so going back to your graph, bring the focus back. If you go back to your graph that you did in question 1, this specifically is asking you for each of the 3. So for instance, helium. Look at, if you were to regraph 0 to just 200, helium would just have this little piece right here. So it's even hard to see on this graph how much area is under that between 0 and between 100 and 200. But look at nitrogen. Between 100 and 200. You want to find this area. So basically what you're doing is you're going to ask Excel, when you graph 0 to 200, you're going to ask it to fit that piece with a quadratic or a cubic, whatever works better, but I think a quadratic probably will fit well. Use it to find the area between 100 and 200. So I could show you real quick as an example. Keep losing focus, eh? So what I did for helium, I graphed it from 0 to 200, and you can see that I asked it to fit it with a quadratic, and the fit was like 3 nines or more, really good. So all I'm doing is I'm going to use that quadratic function from 100 to 200 and integrate it and find this area. That will be the answer to the question. So what's interesting enough is you can write out what Excel gives you like this, right? And then say, I'm going to integrate. I don't have to write the numbers in at first if I don't want to. You're going to integrate this quadratic and see how the C term was a negative number for me. So I took the exact thing it was here from Excel, and I put A, B, and C in place of the numbers, but I kept the negative. Integrate it from 100 to 200. So when you integrate the first term, it's going to be ax cubed divided by 3. This one integrated, bx squared divided by 2. This one integrated would be negative cx between these two limits. So each of these terms, I put the numbers in now next, right? And then you go ahead and do and then when I went one step further, when I divided these, so this was going to get fit between these two, and you carry on, you're going to get a number, which will be a decimal at first, but then you move the decimal over 2 places to get the percent of the area for helium. So for helium, it's something like 0.3 or 0.5% of the total sample is going to have speeds between 100 and 200. And you can do this for each of the gases between 100 and 200. Probably staying with a quadratic is the easiest, because when you integrate, you just keep it to 3 terms, right? I don't care, you know, as long as you got a couple 9s here, and I think a quadratic will probably work well. Nitrogen, I chose a cubic, so maybe it is better. And then for iodine, I'm going to retract what I just said. Remember the curvature, right? Think of it this way. How much curvature was going on here for helium? Not too much. This one I chose a cubic, and then this one, when you go from here to 200, you see how your curve 100 is here, goes all the way over, right? So I used a function that was up to a quartet, so to speak. But anyway, you could run that through and see what numbers you get, and that will be question 2.